Hello and welcome to another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 2, Lesson 10 on more work with multiplying and dividing sign numbers. So today is a lesson where we're going to use what we've learned already with multiplying and dividing sign numbers to extend the topics just a little bit to other things that you've seen before, things like exponents and fractions, right? To extend so that we can deal with those when they involve negative numbers, all right? And we're going to kind of get into it right away in the first exercise, so let's start at it. Here we go. Raising negative numbers to various exponents. So you've been doing work with exponents for quite some time, right? And you've never really had to have a base, that's the number that's being raised to the exponent. You've never really had to deal with the fact that when you take a base and raise it to a power, an exponent, that the base could be negative. By the way, eventually, not in this course, eventually you'll even deal with what happens when the powers themselves are negatives. But you're going to have to wait until Algebra 1 to do that. I'm sure you're really excited. Anyway, let's get right into it. Now, before we actually even get into this particular topic, just remember the overall rule with multiplying sign numbers together. And that's the following. If I multiply two numbers together that have the same sign, they're both positive or they're both negative, the result ends up being positive. On the other hand, if I multiply two numbers together that have opposite signs, one's positive, one's negative, then the result ends up being negative. And we can use those facts then to do these various exponent properties. And let's talk about how in exercise number 1. Find each of the following. Write out as extended products. All right, so let's talk about what that means. Let me first get my pen on nice and blue, right? Here we have negative 2 to the second power, also known as negative 2 squared, right? Well, what negative 2 to the second power means in an extended product is negative 2 times negative 2. Now, of course, if we take a look at that, I've got a negative times a negative, which means the result will be a positive. It will be positive 4. Okay, and that's what happens when we do negative 2 to the second power. Now, on the other hand, in letter B, when we have negative 2 to the third power, let's write that out as an extended product. That's going to be negative 2 times negative 2 times negative 2. And of course, when I'm evaluating something like this, I need to do some grouping. So I could kind of group it like this. I could say, well, it's negative 2 times negative 2, get that result, and then multiply by negative 2. Keep in mind, we just found out what negative 2 times negative 2 was. It's positive 4. So all of this is going to be positive 4 times negative 2. And now, because I have a positive times a negative, my result has to be negative. And specifically here, it must be equal to negative 8. Try to use your result from letter B to help you figure out the answer to C, and then try to use that result to help you figure out the answer to letter D. Pause the video now and see what C and D are. All right, let's go through them. Well, letter C, we have negative 2 to the fourth power, which is going to be negative 2 times negative 2 times negative 2 times negative 2. Now, we can group this in any way we want, but if I group it like this, right, negative 2 times negative 2 times negative 2, well, that's just what we got in the last problem. That's negative 8. So all of this will be negative 8 times negative 2, and negative 8 times negative 2 is a positive 16. Now, if you said, hey, I got positive 16, but I did it by grouping negative 2 times negative 2 together, and negative 2 times negative 2 together, so I got positive 4 times positive 4, which gave me positive 16, awesome. All right, it's just kind of nice, especially when we get to letter D, right? In letter D, where I'm barely going to have room for this, you know, I'll have negative 2 times negative 2 times negative 2 times negative 2 times negative 2, right? I can think about it as grouping it like this, all right, negative 2 times negative 2 times negative 2 times negative 2, but all of this is what I had over here. Right? So that's going to be positive 16 times negative 2, which is going to be negative 32. right? Each time that I raise negative 2 to an additional higher power, I'm just taking my previous answer and multiplying it by that base again. So negative 2 times negative 2 is 4. Then 4 times negative 2 is negative 8. Then negative 8 times negative 2 is positive 16. Then positive 16 times negative 2 is negative 32. And you could probably figure out from there, if I then did negative 32 times negative 2, I'd get positive 64, etc., etc. Now all of this leads us to kind of a cool conclusion that we can talk about in exercise number 2. So let's bring that up right here. Exercise number 2. Can you generalize? Fill in the following. A negative number raised to an even power will have what kind of a result? And a negative number raised to an odd power will have what kind of a result? So think about that. And what I'd like you to do is in these two blanks, I'd like you to either put in the word negative or the word positive. And you can figure that out by kind of looking at that last example. Take a look for a second. All right. Well, it's very, very simple. When we take a negative number and we raise it to an even power, we're going to always get a positive result. And we saw that in the last problem when we had negative 2 to this power, an even power of 2, we got positive. And when we had negative 2 to the 4th, we got a positive. On the other hand, when we took negative 2 and raised it to an odd power, the 3rd or the 5th power, we got a negative result. Every time you multiply a result by a negative, then what happens is it takes the previous result and changes its sign. If the previous result was negative, then multiplying a negative by a negative would give you a positive. Then if you multiplied that positive by a negative, it would give you a negative. Then if you took that negative and multiply it by a negative, it would give you a positive again. And that's why we get this pattern. Anytime we take a negative number and raise it to an even power, the result will be positive. Anytime we take a negative number and raise it to an odd power, the result will be negative. It's kind of a cool thing about powers and negative numbers. Now, there is one thing, though, that's a little bit tricky about raising negative numbers to powers. And let's take a look at that in the next exercise, wherever that thing is. All right. Oh, actually, no. We're going to look at that cool, interesting thing in the following exercise. Let's take a look at exercise number 3, where we simply practice raising negative numbers to various powers. Exercise number 3. Find each of the following. Show extended products and any intermediate steps. All right, well, it's this simple, right? Here I've got negative 8 to the 2nd power. My extended product is going to be simply negative 8 times negative 8. A negative times a negative is a positive, and we have a positive 64. And again, it fits that general pattern that if I have a negative number raised to an even power, the result is positive. What I'd like you to do is pause the video now and figure out what negative 5 to the 3rd is and what negative 3 to the 4th is. Go ahead and figure those out. Now again, we're going to work through the intermediate steps, but negative 5 to the 3rd ultimately should come out to be a negative answer because we're raising a negative to an odd power, and negative 3 to the 4th should end up being a positive result because we're raising negative 3 to an even power. But again, let's take a look at why. Negative 5 to the 3rd, well, that's going to be negative 5 times negative 5 times negative 5. And if I group those first two negative 5s together, negative 5 times negative 5 is positive 25. And then positive 25 times negative 5 will be equal to a negative 125. All right. Now let's do negative 3 to the 4th. All right. That's going to be negative 3 times negative 3 times negative 3 times negative 3. I can group this in a variety of ways, but I think I'm going to group it like this. Negative 3 times negative 3 is a positive 9. And here, negative 3 times negative 3 is also a positive 9. And then as we know, 9 times 9 is 81, giving us a positive result. So it's kind of cool. Negatives and positives, when it comes to multiplying, get wrapped up in sort of how many times we multiply them with exponents. So now let's look at kind of a weird situation that comes up with negative numbers and exponents. And this can throw a lot of students off. Thankfully, we don't have to deal with it too much at this level, but it's something that it's good to kind of have pointed out to you right from the get-go. Exercise number 4. Consider this expression, okay? I don't even want to really read it off. Although this seems like the number -5 is being squared, this isn't quite what the expression means in math due to order of operations. So let's talk about this a little bit, then we'll kind of get into the problem. In all of the problems we've seen so far today, when we have raised a negative number to a particular exponent, I've been very careful to keep those numbers enclosed in parentheses. So like in the first exercise, right, we just had things like -2 squared and -3 cubed, right? I always had those numbers in parentheses. And it wasn't because, it's just the way things are done. It wasn't that. It's because this thing, believe it or not, is very different than this thing. They look like they're the same. It looks like both of them mean the number -5 squared. And yet, this one doesn't really mean the number -5 squared. And let's take a look at why that is. Let me first just kind of delete all of this stuff. So, letter A, fill in. This is simply the same as this. Mathematically speaking, these two things are the same calculation, all right? This is not -5 squared. This is really 0 minus 5 to the second. Now letter B says evaluate the expression on the right-hand side of the equation in A. Remember, exponents come first. So if I'm actually trying to evaluate this, my order of operations says I have to do that exponent before I do the subtraction. And now 0 minus 25 is -25. So this expression, although it very much seems like it should be -5 squared, and let's be very clear, -5 squared, which is -5 times -5, is +25. Okay, there's no question about it. But this doesn't mean -5 squared. It really means 0 minus 5 to the second power, right? And that happens to be a negative. Anyway, if that's a bit confusing, it's okay. It's something that we want to expose you to at the 7th grade level because you will continue to see negative numbers raised to powers. And the best thing you can do when you have a negative number raised to a power is put it in parentheses. Very, very important. We'll talk about that a little bit as we go through more complicated expressions involving negatives raised to exponents. For now, let's move on and look at some other issues. All right. One of the things we want to look at in this lesson are fractions and negative numbers. Now again, fractions are numbers, negatives are numbers, right? And we can certainly have fractions that are negative, right? So let's take a look at exercise number 5. Plot each of the following negative fractions on the number line below. Convert any improper fractions to a mixed number first. All right. This is easy enough. I mean, you were plotting negative numbers on number lines last year in 6th grade math, including some negative fractional numbers. And it's easy enough, right? Like A, which is -1/2, is a piece of cake, right? It's right here. You know, that's not too tricky, right? Here's where our -1/2 is on the number line. And that's all we kind of want to get at is this idea that, like, yeah, I mean, -1/2, it is a number. It lands on the number line. It happens to be left of 0 by a half a unit. Simple enough. A number like -13/4, that's a little bit tricky because in order to kind of properly locate it, we might want to think about it a bit. Now, forgetting about the negative for just a second, if you wanted to think about plotting 13/4, right, you'd want to convert it into a mixed number. So 4 goes into 13 3 times, right, with a remainder of 1. So that's really -3 1/4. The negative is attached to the overall number. Where's -3 1/4? Well, there's -3, there's -4, there's -3 1/2, and therefore -3 1/4 would be right about there. You know, I might not be able to plot it in its exact location, but I can come pretty close. Okay, what I'd like you to do now is pause the video and figure out where points C and D should go on the number line as close as you can get it. All right, well, we should be able to locate letter C without any issue. Negative 9/2, right? If I convert that into a mixed number, that's negative 4 1/2. And that at least I can find. That I'm trying really to get that 1/2 there. That should be no problem. It's over here. Negative 15/8, that's a little bit trickier. That would convert into a mixed number, negative 1 7/8, right? So here I've got negative 1 1/2, negative 1 3/4, negative 1 7/8 would be right about there. All right, great. And again, the whole purpose of this exercise at all is to recognize the fact that negative fractions exist. We can locate where they are on a number line, right? And we can plot them. Now, what we want to look at, though, is what happens when you get a fraction where maybe the numerator is negative or the denominator is negative or both of them are negative, and how to be able to think about that fraction. So let's get at that idea in exercise number 6. Here we go. Fractions and division of integers. Exercise number 6. Consider the two division problems expressed in fraction form, negative 3 divided by 2 and 3 divided by negative 2. All right, so let's break out of this just for a second, right? These two things are obviously fractions, right? Because they're fractions. They've got the fraction bar in them. But we can also look at them as division problems because all fractions can be thought of as the numerator, the number on the top, divided by, the fraction bar is division, the number on the bottom, the denominator. Numerator divided by denominator, right? So letter A asks us to explain why both fractions must be negative. All right, so why would both fractions have to be negative? Pause the video now and see if you can answer that question. All right, well, it's this simple. In both fractions, and I'll write this down in a moment, but in both fractions, we have division of two numbers where one is positive and one is negative. That's that simple, right? It's because we have division of two numbers, and here I'll even make it shorter, of opposite signs. That's it. We have division of two numbers that have opposite signs. In this case, we have a negative divided by a positive. In this case, we have a positive divided by a negative. And that means that the overall fraction must have a negative value. It has to have a negative value. And letter B says, both of these fractions are equal to what negative rational number? You see, I don't really want to leave these things as fractions. This is a horrible way to look at a fraction because what does this thing even mean? This one, at least, I don't know, I feel kind of comfortable with. This is just completely warped and twisted. But the whole point is, you know, just like all other division problems involving negatives and positives, when I look at these two, I can say, well, I have a negative and a positive being divided, so the answer is negative. And specifically, the answer is simply negative 3/2, or negative 1 1/2, or negative 1.5, right? Both of those two numbers are equal to these three because they're both really just calculations, division calculations that result in a single number, which could be expressed as a fraction or another fraction or a decimal, and it happens to be negative. So what we're going to do in the next exercise is we're going to look at a bunch of fractions where there might be negatives in the numerator, negatives in the denominator, possibly in both, and we want to write them as either a positive fraction or a negative fraction in sort of simplest terms. So let's take a look at that in the last exercise of the lesson. Here we go. Exercise number 7. Rewrite each of the following division of integers as a positive or negative fraction in simplest form. Do not convert into mixed number form. Not that there's anything wrong with mixed number form, I just don't want you to waste the time doing it. So here's what I'm getting at. In letter A, we have positive 8 divided by negative 6. That's truly what we have. And because we have a positive divided by a negative, the result must be negative. Okay? Whatever the result is, it's negative. And specifically, it is simply the negative version of 8/6, which we can then reduce down to, in simplest form, as negative 4/3. All right, so the negative becomes attached to the entire fraction as opposed to just its denominator. Now in letter B, I have a negative 12 divided by a negative 24. And since I have a negative divided by a negative, my overall answer is positive. Now, I'm going to actually put a little positive symbol down there. You certainly don't have to do that. And in fact, some of your math teachers may not want you to do that. I'm just trying to emphasize that when I have a negative divided by a negative, the result is a positive. The question is, a positive what? Well, 12/24, hopefully you all look at and go, oh, that's 1/2, right? I can divide both the numerator and the denominator by 12. So we get a positive 1/2. And again, it is completely okay to just write this down as an answer. Okay, these are the same thing. Here, you got to have the negative sign. There's no getting around that. But either one of these would be fine. Letter C, right? We've got a negative divided by a positive, right? Negative 15 divided by positive 18. Since we have a negative divided by a positive, our answer has to be negative. And now if I want to simplify it, I simply have to think about what 15/18 is. I can divide both 15 and 18 by 3. 15 divided by 3 is 5. 18 divided by 3 is 6. So that is all just negative 5/6. All right. What I'd like you to do on all the rest of them, including letter D, is I'd like you to do what we just did. I want you to think about the numerator and the denominator. Think about whether the overall fraction should be positive or negative, and then simplify it as much as you can. Pause the video now and take a few minutes to do this. All right, let's do it. Letter D, we've got negative divided by a negative. Negative 35 divided by negative 20. A negative divided by a negative is a positive. So let me put that first. Actually, I'll just write it down here where we actually have some room. And then 35 divided by 5 is 7. 25 divided by 5 is 4, so we just get positive 7/4. All right, let me move the screen up so we can tackle these. Negative 27 divided by positive 15. Negative divided by a positive should be a negative. I can divide 27 by 3 and get 9. I can divide 15 by 3 and get 5, so we have the fraction negative 9/5. All right. Letter F, I've got a positive divided by a negative, so overall I've got a negative. I can divide the numerator by 10 and get 8. I can divide the denominator by 10 and get 11. So overall I have negative 8/11. Letter G, I have a negative 26 divided by a negative 8. Overall that fraction must then be a positive because a negative divided by a negative is a positive. So I can then divide 26 by 2 and get 13. Or I can try to get 13. I can divide 8 by 2 and get 4. So I get positive 13/4. Or I'm going to try to. That's a dead portion of the screen. And letter H, you never know. Some parts of the screen just don't want to write on. I have negative 56 divided by 48, right? A negative divided by a positive is a negative. I can then divide the numerator by 8. And negative 56 divided by 8 is 7. Or 56 divided by 8 is 7. And then 48 divided by 8 is 6. So negative 56/48 is negative 7/6. So it's very, very simple. But the overall idea is that you can get three fractions that look very different but are all the same. And a great example is negative 1/2, right? So negative 1/2 could look like this, or it could look like this, or it could look like this, right? All three of these things are the same number, right? And they're all really the number negative 1/2. It would even be hard to say what these two numbers are. You wouldn't even be able to really talk about them as numbers. You'd have to do things like 1 over negative 2 or negative 1 over 2. But ultimately speaking, those are all equal to the fraction negative 1/2 due to simply the division laws of dividing positive and negative numbers. All right, let's wrap this up. We really saw two different things today, pretty much two very different things. One of them had to do with multiplication, And that was the fact that when we raise negative numbers to exponents, we can either get a positive result if the exponent is even, or we can get a negative result if the exponent is odd. And we also saw how to take fractions where the numerators and denominators could be positive and negative numbers and simplify them either into an overall positive fraction or an overall negative fraction. All right, both of which should be pretty easy topics to handle. All right, I just want to thank you for joining me for another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.